So yes, we have already discussed about this thing and the splitting energy and 10 dq value, and this part is again dependent on the metal atom or the metal ion and also the ligand. So if the ligand are placed in the left hand side in the spectrochemical series, so they will have the, they will actually make the higher splitting energy. Okay, but if they are weak, then this energy gap will be low. Okay, so what will be the result? So just think, if your energy level is like that, okay, and if your energy level is like that, okay, so here if one electron is present, so there is a very close chance to jump here, okay, but in this case if one electron is present, so there is a rare chance to jump here. Is this clear?
Yes, sir.
Yes, sir.
Okay, and another thing, so I have already told you that electron will be filled like this if the 4 electrons are present, okay, but if the energy is too high, energy is too high, this energy, then this electron will be not go up. In that case, the electron will be remain here. Okay, so this is only the case when the ligand are strong field ligand, like for cyanide, nitro, ammonia, water, etc. Okay, so in that case, the pairing of electron can take place. Okay, this is clear.
Yes, sir.
Yes, sir.
Okay, now the write up, that is, if the crystal field splitting energy is greater than pairing energy, that means, try to understand here electron. Okay, so if you just fill the electron in such a way, so there is no of pairing energy, electron pairing energy, but if the system is like that, so then you know that there is a pairing energy, because if electron placed in the singly, then it is more stable. So when the two electron come in same orbit, then it actually face the repulsion. So now, if energy is too high, okay, so then the electron will be come here. Otherwise, it will be go up. Is this clear?
Yes, sir.
Yes, sir.
Okay. So that means if, sorry, so if this value, that means if it is the strong field ligand are present, then electron will be going pairing, and in that case it will form a LS complex, or better it is called low spin complex. Okay, so if the electron are present in this fashion, so here the spin multiplicity will be maximum, because all are in the unpaired state, but here the two unpaired electron are present. So low spin means the spin multiplicity is decreases. Okay, clear?
Yes, sir.
So if the energy difference or the splitting energy is very high, then it will be form low spin complex, and if it is not too much high, then it will form high spin complex. Okay, and if you just think D1, D2, D3, this type of the system, so if the D1, if you are thinking about the D1 system, so then this type of the complex will be stabilized by 0.4 delta O value, or you can say minus 4 10 dq value. Minus 4 dq0, dqo actually, minus 4. Is this clear?
Yes, sir. Yes, sir. Yes, sir.
So I have already written here, it will be 10 dq. Okay, so sometime it is written in capital D, or sometime it is if you someone by written in small, so don't feel any ambiguity. Okay, and if the 2 electron, if we are looking that, it is a much more stable. Okay, and if it is a 3, yes, it is the maximum stable, that is minus 1.2, or you can say 12 dq value. Now if it is another 1 electron will become and go to the higher energy, then again it will be decreases. Okay, now in case of the 5, like iron 3, so CFEC energy is 0. So these all value are negative. That means they are saying that octahedral complex will be stable. But here in this case, this is not giving any information. So in that case, it may be octahedral, it may be tetrahedral. Okay, but you know that in the tetrahedral, the separation angle between the two bonds is the maximum 109.28. So follow they will form the tetrahedral structure. So this is an answer for a particular question. So please tell me that have you understand this thing?
Yes, sir.
Yes, sir.
Again I am saying, so these all are actually negative value. So that means they are saying about the stability of the octahedral complex. But here they are not giving any information for the D5 system. So in this case, we cannot say that the octahedral complex will be get stability. So here the tetrahedral complex will be formed because in the tetrahedral complex the spacing between the two ligands are the maximum, or the distance between the two ligands is the maximum. So that's why they will go for the formation of the tetrahedral complex. Now similar thing is for D6, D7, and all the thing. Okay, and please remember, so for D0, D5, D10, okay, if you follow the electron fill up in such a way, so all cases CFSE energy will be
0.
0. So in that case, most of the tendency they will form the tetrahedral complex. Clear? And now I am saying about the low spin. Okay, that is strong field ligand. So up to this, there is no question of pairing or other thing, because up to this high spin and low spin will form the same thing, because it will be singly filled. But after that, when the four number electron will become, so in case of the low spin, that will be come here. Is this clear? And yes, it is stabilized by this amount, and also by need some pairing energy that actually minimize the thing. But as delta 0 value is higher, okay, than P, so obviously that part will be deleted. That means it will be compromisable, and ultimately we will get some negative value. Is this clear?
Yes, sir. Yes, sir.
Is this clear? Okay. So,
Yes, sir. Yes, sir.
okay. So that's why that will be get stability. Okay. And in case of the 5, yes, again. In case of the 6, again. And look, and in case of the 7, again. And in case of the 8, so there is no question of pairing. Okay, so they will just only fill in normal way. D7, 6 electron, and if it is 1 electron can go, but it will be not go, it will be remain here. Okay, and as there is a completely filled up, okay, so that actually giving the negative value. Then this, and again for the D10 system, you are getting the CFEC energy 0. Clear?
Yes, sir.
Okay, so this is the comparable and strong field ligand. For weak field ligand, this energy is low, and strong field ligand, this energy is very high, and ultimately it make lots of change, because if you think about this complex, okay, so this is paramagnetic, okay, but if you come to the 4 electron system here, that again also the paramagnetic, but the magnetic momentum or moment value will be decreases. Clear? So this is a 6 electron system. Okay, so if you come here 4 number of electron are there, but here yes, it is paramagnetic, but here it is a diamagnetic. Okay, so it will be depend on the ligand. So I have already told you about this thing, high spin and low spin. So these are the, it is not required, student, but these are the picture basically, how they are facing the density of the electron or repulsion. And then tetrahedral splitting. So tetrahedral splitting is just opposite of octahedral splitting. Okay, that means here the along the axis energy, or sorry, orbital will be get stabilized, and in between the axis orbital will get energized. Okay, and here this splitting energy is called